in step number 4.
Right.
What I find as an issue is that the whole world of people out there who are non-engineers
Right.
probably need it just as much as anybody else.
Right.
I have absolutely no exposure to it. I meant it more from the need.
I think that's exactly our goal in sort of trying to do what we're trying to do is make it easy, remove the barriers, sort of. I feel like this is something we could be teaching all streams of engineers or all streams of scientists or all streams of people from different walks of life.
So maybe this is the chance to at least sort of mention the teaching philosophy from this funny blog site. Should I go ahead and do that? Or?
Yeah.
People were asking me like, what kind of machine learning am I teaching? What specific topics? And to me, what the real point was. To me, what the real point was. No, I'm good, thank you. So. Is there are many topics one could teach, but this was actually my ultimate goal this week. There's this rather amusing blog, and I'll put it up. Oh, is it?
I'm sure many people have seen it.
Every once in a while, yeah. Is there a way that I could at least keep that screen up for just a moment?
Here, there you go.
So I found this a rather funny website actually, but there's a real grain of truth in there, and one of the things that gets pointed out is this one right here, and I'll just sort of highlight it because so somehow people feel that some people anyway feel that they have this big Google envy. Any Google employees here? You better be careful. Or anybody? You're an ex-Google is okay. Or anybody out there, and I don't know who's out there.
I'm not saying anything bad about Google here. I mean, it's
that's true.
Right.
Well, I mean, I don't know if you look at the title, maybe that would be a little offensive to somebody at Google. Anyway. But I think even a Google employee would agree that if people have the notion that's highlighted right here, which is that like somehow people who work at Google are more intelligent and competent than yourself, and therefore you'll never be able to compete. What my goal for the week was to convince people that there's no truth to that whatsoever. That you could learn these skills and you could be on par with anybody at Google and go and build your own machine learning platforms that solve your own problems and may even do it better than anybody at Google. So what I tried to do is build for this week the confidence that this would be absolutely possible. And one of the nice things about the Julia language is that Julia makes it very easy to teach people this. So maybe this is, now that we're actually getting some screens up, maybe I'll sort of start the real story here, tell you a little bit about Julia. You might have already seen the website, the Julia Computing website. So Julia is being used in quite a lot of applications these days, and here's the astronomy one was a good fun one, and you can see, I mean, you could actually go to the Julia Computing website yourself and see sort of the many areas that Julia is being used in. So it's quite a general purpose language. People would often ask, is this good? Is this the language for statistics, or is this a language for linear algebra, or is it? And the answer is yes, and it's a general purpose language. And in part, that's where the power comes from. Julia right now has. Julia is very fast, and I'm going to show you some concrete examples of that. Julia is the only sort of interpreted dynamic language that has reached the petaflop club. I don't know if people here know what that means, but flops are floating point operations, pluses and times, and maybe the human can do I don't know, a couple of multiplies a minute. I don't know if they're small enough. Computers are measured in speeds. Megaflops is 1,000,000 multiplies and adds a second. Gigaflops is 1,000 of those. Teraflops is another factor of 1,000, and petaflops is yet another factor of 1,000. Okay, so I even lose track of the millions times billions number that I just said. But Julia.
Better stand to the power 15, I think.
Yeah, well, it just boggles the mind. And it's always been a belief that that you have sort of two choices in a programming language. It could be very fast, like C, but somewhat harder on the human, this is sort of a language for the computer, but not for the human being. Or you could have sort of interpreted languages, like you brought up the issues of R and MATLAB. And these languages are slower, but they're easier to program in. And so humans like to use these languages a lot more. And it was always a belief, almost like it was a law of physics, that you could have one or the other. You could have your fast language, or you could have the easy language, but you can't have both. And with Julia, we set out to prove, and we have, that you actually can have both. Right? And so that's kind of what Julia is about. And so if you go to the Julia website, or in fact, if you Google Julia, let's just do that. If you Google
Julia Roberts?
If you Google Julia, so the Julia language, Julia Roberts is like way in the dust these days, the actress. So you'll get to our site, and you could see some statistics on speed. I mean, I'm not going to go through this, but just to let you know that there are these speeds here. 10 to the 0 is 1 as a ratio to C, and so C is right there at 10 to the 0. 10 to the first means 10 times slower than C. 10 to the minus 1 means 10 times faster than C. And you can see that Julia is within small factors of C, while all these other languages are all over the place, sometimes even orders of magnitude worse than C. And so, but these are just benchmarks. I always tell people to write your own code, and then you'll see just how fast Julia is. Julia is also very, very easy to use, though. And so this whole petaflop club thing, in fact, I've got slides, but it's more fun to just Google these things. So petaflop club Julia, I don't know, see if something comes up. So here we go. So here's, our website, but is there another one that, or the HPC wire is sort of
probably the same thing.
Is it the same thing?
The communication with AC.
Okay. But in any event, so the fastest computers in the world run at petaflops, and so this was run on one of the fastest computers in the world, and this was the astronomy application. All right, so let me see. What should I tell you? I'm tempted. Yes.
Can I just maybe just since we have just started the recording as well, just to give a little intro also.
We never had this intro, did we?
Yeah, we did. No, so one of the at least thoughts I had, looking at everybody who registered, we have SaaS companies who registered. Unfortunately, we couldn't get online, but we had a lot of fintech companies.
So the only people hear me are in the room only?
Primarily, these are the only people in the room. We are not able to get online.
Okay.
What we'll do is we'll record and upload it online for people to view it later. So there were a lot of fintech companies as well, online, because many of them are not based in Bangalore.
Okay.
So they were planning to join up, and there is a lot of thinking or sort of around how AI/ML can be a strategy for many of the product startups, in the SaaS space or in the fintech space or in some of the other spaces as well. So that would be a good sort of outlook if you can also help understand that, and where Julia helps navigate that strategy for them as well.
Right. Okay.
Right? So I think mixing, having that would be a very unique sort of session for the founders here.
So let me do exactly that.
Okay. Awesome. Thank you.
Okay. So.
Perfect.
Yeah. So in terms of these sorts of machine learning strategies. Again, now that we actually have the visuals, I can actually show you. This was the group of people that we were teaching right here this week. So this is the group photo. There were about 80 students, many from Bangalore, but not, people coming from various other parts of India as well. This is exactly what we're doing, which is sort of showing why Julia can really enable you in machine learning. And so what we taught them was what we taught them on day one. We showed them a little bit of Julia, and in fact, at first we showed them some code, and a student fell into my trap. I was kind of proud of them. The student raised his hand and said, this doesn't look like the sort of code the way I do it. It looks like it's going to be hard to do. I'm not sure, but I think it's going to be hard to read. And the next day, the student was writing code in exactly this way. and was saying that like they can't even imagine writing the code in any other way because it's so readable, so easy to change, so flexible. And by the next day, what we had every student do is implement a complete machine learning package from beginning to end to do a handwriting system. And in fact, the system that they built was able to recognize their own handwriting. So what they did was, there was a web interface, and they actually would write down, this was a system to recognize digits, something very easy. And so you'd write your own digits, you write down the number 7 or the number 8 or the number 2. And the system that they built, with our help, of course, but the system that they built.
People, some of them might be familiar with the MNIST data set of handwriting.
Yeah, that was used for the training, but in the end it was their own, they ran it on their own handwriting.
So usually when you download a machine learning library, right? Like they make you first download this MNIST handwriting recognition data set, and then they just have this one function called train, and then you just train it, and then you're told magically now, this AI has learned this thing, and you feel like, great, I wrote the hello world of machine learning, and now you're given, and to your point, right? Like now I want to actually apply it to something that I'm trying to do, and what do I do? I'm kind of at a loss. And what we did here is instead we sort of, did the whole algorithm from scratch, right? And I think this is something
right. Complete A to Z, where you have the data loaded, you actually go through the linear algebra, the whole, we taught them about the gradient descent, and all the pieces, so they can even show them where good software engineering comes in. That this is not just an engineering hack to get the job done, but what are the pieces that you really need so that it actually becomes easy to have it. And Julia makes it easy to be able to do that sort of thing. I wasn't really going to do this, but I love to do things on the fly. So let me see if I can find. Let me see something I was doing earlier today. Let me see if I actually have it handy. Maybe right in here I can see if this will work. So
please ask us questions and interrupt us, otherwise we just
so this is something I was just showing them today. I'm not going to. There's a lot of Julia code here, and I'm not going to explain anything about what this is. And if Viral tries to, I'm going to stop him from explaining what any of this code does. But just to give you a sense of how easy Julia is, you don't need to understand any of this, Julia. Don't even try to read it. The point is, here are some sort of words that come up in machine learning. Maybe some of you know these words. This is a deep neural net, and if you haven't seen some of these words, you can actually Google them. I mean, I'll pick one of the words, the LSTM, which is long short-term memory, which is sort of like a big deal if you've ever gotten into this business at all. The kinds of neural networks that people work on, and learning this stuff might seem very daunting. If you read this blog, actually, it's meant to be somewhat helpful, but pretty quickly you walk into these equations, and you don't even know what the notation is. The vector, you don't even know what's going on. So, in order to enable the students, I showed them why this question that you're asking, why Julia? Well, the reason for Julia is because if you have, and I've got which one I was using. Is it this one? Yes, this one. Here's that LSTM in there. I was showing them that if you don't know what this stuff is and you want to learn it really fast, all you have to do in Julia is grab one of these things and you can drill down. And this is, as Viral was saying, if you're just a user, if you want to get inside this stuff, it's practically impossible. With Julia, you can just sort of grab this stuff, see, oh look, I don't know what this thing is, but whatever it is, it's got 14 objects, 4 of which are 2-dimensional matrices. These are 128 by 196 matrices, and the other 10 are vectors of size 128. And then you can go back to these blogs and say, now wait a minute, let's take a look. I had 4 matrices. Oh, look at this picture here. There was this. And you can do the match. So, you were talking about sort of the theory. Yeah, I could put something up on a blackboard, but if you don't see the code, you don't really, it becomes like confusing. You don't really. If you have the code and you don't have an explanation, then also it just looks like a bunch of code. But you put the two together, and you have a playground where it's easy to play, it's easy to recognize what things are. Boom! All of a sudden, you know what's going on. You get the confidence, and you can actually build this thing and move forward. So that's one way where Julia is very useful. Julia also, the notation, I mean, I'm not going to show it to you here, but I just showed it to a bunch of students this week who've never seen Julia before. And the Julia notation is very expressive. It actually lets you do in what would be 20 lines of Python or in some other language. Julia just does it in just a small number of easy-to-read characters. And so this is actually very useful because when code starts to fill up too many screens, forget it. We humans, we lose track of what it is. But if you can say it concisely, so you kind of see the big picture, not the little picture, then you can really sort of, you can own it, you can change it, you can do whatever you want with it. And these are some of the ways that Julia really enhances machine learning. So, so there are a number of different things I could do right now. I mean, I've got these PowerPoint slides. I could kind of sort of show you Julia being fast in action. I don't know if there's anything like this to see.
What's of most interest, yeah.
Yeah, well, but I don't want you to tell me, bro. I'm done. So you don't tell me. I want them to tell me. So you want to see Julia being fast? You want to see some slides of how Julia is being used? What would you like to?
What are some of your sort of queries, right, in terms of Julia and largely AI?
Maybe a comparison between Julia and Python.
You want to see a compare? Okay, in terms of speed or in terms of expressiveness or both?
Yes, both.
Both. All right. So all right. So here I've got. Which one is this?
Actually, I have a simpler question.
Okay, please.
Usually, any programming language depends on the community developing around it, right? So.
Well, that's been the tradition. That there are these. Like in the movies, there's the person who's you get typecast, right? Actually, you could be the villain or you could be the good guy, right? Computer languages get typecast by their very communities. That statistics languages and matrix languages and so forth. The great news about Julia is that it's been more inclusive. In fact, it's done what has been hard to do, to get people in different communities to work together. This is sort of the social aspect of an open source language, which for me was a phenomenal thing to see, because I always thought that these communities would never work together, but in the Julia world, you didn't really finish your question, so I was anticipating, but was that kind of your question, or?
Yes and no.
Okay.
If you take something like Python, there's a lot of libraries available if you want to do something else that's not directly available in the language.
Sure.
Like Google's TensorFlow is built on top of Python, right?
Yeah,
it's the other way around.
Not true, right?
Yeah.
We'll ignore that for the time.
Yeah. TensorFlow is not. Yeah. You can call TensorFlow from Python, but yeah. But
you can call TensorFlow from Julia.
Yeah. And in fact, there's a.
It's not built on Python. It's actually.
As a matter of fact, just because you mentioned that, I was just happened to somebody asked something similar today.
But I think that was not your question.
But maybe your question is.
So it kind of answers the question. You're saying you can call TensorFlow from inside Julia.
Yeah, you can actually call anything from, especially anything in Python from Julia. So you haven't lost anything, and sometimes you even gain. And so one of the reason why I brought up this was a talk that was at JuliaCon last summer, which was over at Berkeley. I'm not going to show the talk, but I'm just going to go so we can get to the front here. I don't know if I have enough bandwidth, but in this talk, what the speaker did was he showed why, if you do call TensorFlow from Julia, well, there are many advantages that you wouldn't, that you don't even have if you called it from Python. So yes, you could have the full. If you want all of Python's libraries, it's completely easy to call from Julia. In fact, I'm going to show you, in response to this previous gentleman's question, I'll actually show that's in action. So you're not losing anything by using it in Julia. Okay. So, and all of these libraries are in many cases, I think in the big majority of the cases, are not really written in Python at all. These libraries are written in perhaps C or some other thing, and just have kind of like a thin front end. Python itself is really just like a thin front end to C in many ways. One big difference with Julia is Julia all the way down until you sort of get down to the lowest level LVM. But most of Julia is just sort of Julia all the way down, and that makes a big difference, which I'll explain later. But it actually makes it a very different kind of. You might think all languages are the same. They're just a way of expressing something. But Julia is different because of its construction. So here, let me show you.
Julia has its own packages, about 1,500 packages, which are all first class.
No, I think his question was something else. He was talking about in Python you can easily call any kind of model through scikit-learn. You can do data manipulation through NumPy or Pandas and all.
Yes.
So how?
Let me see if this doesn't answer your question, because I'm gonna do exactly as you said, right here, right in front of you. So I have this little demo notebook which I like to show people, which answers both the speed and the interoperability, I think, in one fell swoop. And so, and it's also kind of fun to, a little bit of a horse race here, so I think it's kind of fun to watch as well. So let me see if I can sort of pull this off. So I've got this notebook, which I've sort of, it's sort of a kind of streamlined version of a notebook built by my colleague Stephen Johnson, who's a real speed demon. And we use this in a course at MIT. And we try to explain to people how it's possible that Julia can be as expressive as it is, how it's possible to call all these languages and still be very, very fast. So what we do is we demonstrate it with a simple function here. Oh, you know what I'm going to do? Let me clear the whole thing so that you don't believe I'm cheating. So yeah, let's clear the whole output. In fact, let me do the following. Let me just actually reboot the whole kernel. Yeah, restart and clear output. All right, so this way you know I'm not cheating. Okay, so let's just have that happen. So I'm going to work with the, yep, there it is, it's all being cleared. I'm going to start with a very simple function. You know, this is not higher mathematics by any means, the sum function. All right, I got a vector A, and I want to add up all the numbers in A. Just as a simple example, you know, I can make it arbitrarily complicated if you want, but let's start simple, the sum of A. That's all I want to do here, okay? So the first thing I'm going to do is generate some data. So I'm going to generate 10 million random numbers, random floating point numbers between 0 and 1. So here's 10 million numbers, you see them? All right, I've got dot, dot, dot. But these are 10 million random numbers, so the mean is a half between 0 and 1. And I'll ask a quick question. Who here can add real fast? What's the sum of 10 million numbers? This is actually answerable. That's a hint. So, yeah. So it's 10 million numbers with average half. 5 million, right? You've got to get that decimal point there, right? But one of the hardest things in the world to do, I hear, is to get that decimal point right. Yeah, so it was 10 million numbers, mean half, so the sum is about 5 million, right, approximately. In fact, what it was, in this case, this is 5 million and 1,114. Right? I run this all the time. I get a different number here all the time. But maybe we'll remember 5 million, 1,114. Okay. And what I'm going to do is benchmark this code. And so let me just start the benchmark going, just to sort of get things going, so we can actually do some really good comparisons. And the very first benchmark that I'm going to do is I'm going to use what some people consider the speed of light in computing, the C language, right? So people think that the C is always going to be as fast as anything can possibly be, right? So one of the things that's easy to do in Julia is actually write code in another language. I mean, this is already a bit of a preview of the interoperability from Julia. And so whether you speak the language of C or not, or even if you're not a coder, I don't think it takes much for you to realize that how this is adding up a vector. So we're going to initialize a sum to be 0, and what we're going to do is one by one, we're going to fold in x of I into our sum until we finally have added up all our numbers, right? So whether you've ever coded or not, or if you're a C coder or not, I think it's quite easy to see that this is going to accomplish the job. Okay, and so in this code right here, we not only write the code, we're going to compile the code, because that's what C requires, and we're going to call that C code from Julia, and we're going to define a function which will do it all for us. So all in one fell swoop, I've just added a C function to my Julia. Okay, this is not how we really like to operate, but and look, by the way, we've got the same answer. I mean, I don't know if you remembered the number, but I remember it. It was 5,001,114. I don't usually get so many ones in a row, so this I don't know, you got lucky this time. It's easy to, right? So, do you remember the number? It's back up here somewhere. There it is, 5,114. As a matter of fact, So let me make sure everybody understands what just happened. We just defined in Julia a vector A of 10 million numbers, and I wrote a little C program, and I'm calling this C program on my Julia vector, and I'm getting the answer. That easy, okay? So, and if, by the way, if I try to calculate the sum, the difference, just maybe as like a real check, between the C sum and say, let Julia sum, you notice that, oh, there is a little bit of round-off error. There's a bit of a difference. And this is not anything to worry about. In fact, this is a good thing. The C program I just wrote added the numbers from left to right. And Julia does something that's considered more accurate. It does a pairwise and then a pairwise and pairwise again. So it doesn't add up numbers in a different order, in the same order. And even though we all learned that you can add up numbers any which way and get the same answer when you're in first grade, on a computer that's not quite true. There's always round-off errors. So if you add up numbers in different ways, you get slightly different answers. And this is not a problem. This is just the way computers work. But in Julia we actually have this approximate function. So you just type \approx and tab. There are a lot of things you could type in Julia. That are kind of fun. If you like Greek letters like pi, you could type \pi and get the number pi. If you actually like symbols like heart suit and hit the tab, I can make heart suit equal to 17, and then I can go. So I mean, some people find this kind of fun actually. It's like you could go this plus heart suit. You can, and oops. And you could set variables to all sorts of things. In the course that we just did, I don't know why, but we fell into this, but they just loved it. You can do a smiley cat. Did I do it right?
Underscore between smiley and cat.
Yeah, I never get that right, so this is why I cheat and do this. Okay, so there's the smiley cat, and you can sort of blow it up if you can't see it. But, whoops, I'm blowing up so much I can't find it anymore. But, yeah, there's my smiley cat right here. So, you can, anyway, I don't know why, but like they went crazy with that today in the course. All right, but back to the main story here. Let me put it back. So where were we? We were writing a C code. Yep, that's what we're doing. And oh yes, checking that the sum is a here do the help. But let me get to the main story here. Here's some, because we love speed in the Julia world, we have all kinds of benchmark tools. So completely speed obsessed developers. So we have these benchmarks, and you run. The best way to benchmark is not to run something once, but to run something many, many times. And the fastest time we got was about 8 milliseconds. Okay, so let me sort of cut to the chase. I'm going to keep track. No, did I not? What did I do here? Did I not? Just a second. Did I not run the? I wanted to show a picture, but if I don't have it, it's not a big deal. Okay, but here, let me talk about this just a little bit. Okay, so we have this benchmark tool which will run something about as many times as I have the patience for, and depending on whether something's small or big, it might take more time or less time. In this case, it ran 388 times, and the slow poke one here ran at 30 milliseconds. The fastest was at 8 milliseconds. There's a median and a mean. And one of the things I like to show my own students is that you can't just run something once, or you can't just take an average. When you really want to benchmark, benchmarking is actually a very complicated business. And so what I actually like to do is draw pictures of times. And so like here's, for example, is a histogram of the various times. And so that's much more fun to see. And we just sort of get that. So here's sort of the fastest, here's the slowest as well on the right somewhere, and you could see that there's always this sort of range of times. But in any event, we've got our first horse has come in, and I want you to remember, though, you don't really have to remember because I'm keeping track for you. The C program ran in just short of 8.8 milliseconds, okay, just to sum up the numbers. All right, now, what about, speaking to your point, what about making the Python call from Julia? Because there's all of these packages in Python, and you don't want to lose them all from Julia. Well, here's an illustration. We're going to use a PyCall, and I want to call the Python built-in sum function right now, and I want to make it into a Julia function. So that's exactly what I did. And so now I'm going to have Python add up all the numbers, and yay, it is also 5,001,114, right? You all recognize that number now, right? You've got it in your head? Has the same sum to so many digits. So let me make clear what's happening here, in case it's not. In this case, we are calling Python's built-in sum function. Now, I mentioned before, Python is not really a language all the way down. It's just like a little front end to C, right? So what I'm doing here is I'm calling Python sum, which is calling C to sum up the numbers, okay? And when I do that, we can actually go ahead and run the, again, let's just get some more of these going so I don't have to wait for the benchmark. But here, let's get, and you can see that Python's built-in sum, which I'm going to be benchmarking right now, oh my gosh, it ran at 74 milliseconds. So here's the horse race so far. We ran some C code, took just short of 9 milliseconds, and we just ran it in Python, and it's like 74 milliseconds. Actually, the funny thing is, these are both C codes, really. It's just Python calling C versus sort of our own C program. And, why this is happening is a story by itself. I could tell you if you really want to know, but right here, I mean, sometimes people very rarely compare performance in different languages. You don't even realize that there could be whole orders of magnitude difference, even on something as simple as sum. But here it is, sort of laid bare for us all to see. Okay, but people who use Python, they know that, okay, raw Python sometimes is slow. Let's call a library like NumPy. And NumPy is actually a very fast library. And so let's go ahead and, I just ran it just before kind of like, a cooking show where I've already like finished the product so you can see the answer here. But on my laptop, NumPy was, look at that, it was twice as fast as C. How could that be? Right? I mean, and there's an answer to that. Should I tell you? Do you want to know what a NumPy code was twice as fast as C? Should I tell you? But before I do, all of these are C codes. That's the key thing. These are all C. It's just better C and worse C in a way. So what's going on here is even on a single processor, there's parallelism. A lot of people don't realize that, but processors today are so fancy that even if you have one core, you can get parallelism. You can actually add up. You can get 2 streams of addition going on my Mac. That's where the factor 2 is going to come from. There's a word for it. It's called SIMD, but let's not worry about the word. The key point is that you can actually do 2 adds a cycle, but there's a little bit of a cost involved, a little bit of a cheat. You can't keep the order of addition the way, if you insist on it going left to right, you can't have that anymore. So in a way you're cheating a little bit. You're saying, I'm going to mix it up a little bit. Like, if I were, I was actually signing certificates this morning for the students. And, I was doing it in the order I got it. I signed the top certificate, and then the next one, and then the next one. If I wanted to have Viral here sign my name, I don't know if that would be like breaking some laws or something, but if I wanted to do it in parallel, I would probably give him the second half for the batch, or maybe I'll give him all the odd certificates. I don't know, that'd be more complicated, but probably what happens on a computer. And we would not be signing in the same order anymore. So the C compiler that I was using was not chosen. I didn't optimize to allow for that. You have to give special permission to the compiler to reorder the numbers, and that's why the C program didn't do that. But the NumPy says, let's go for the speed, and it does do that. All right? So we get that factor of 2 from NumPy. All right. Let's go all the way and do this in handwritten Python. So you see the difference? The first one was Python's built-in sum, which is, like I said, is a C call of its own. The next one is Python's NumPy, which is meant to be a screaming C library. And now this is, like, honest to goodness, real Python. Okay? So, can I ask you a question? Is this big enough? I sort of feel like we're wasting screen space by putting my picture here. I don't know if there's something we can do about that, but can we just make the whole thing big for everybody?
Let me see if I can do
You all see me, and nobody else, I mean, there's nobody else in the world watching me, right?
No, actually we are live for some...
Oh, we are live?
Yeah, so Karthik did some magic and we are live.
Oh, I see. Oh, so maybe people do want to see me, okay. Because people in the room see me, they don't need to see. I see. I still think a full screen mode would be fine. You don't need to see me.
How do I do that?
Top right corner, the speaker view.
Speaker view.
Beside the speaker view. Yes.
Oh, it still has that.
Oh.
All right, well, you tried. I could also make it a little bigger. I just want people to be able to see
I
it.
think it's fine.
It's fine?
pretty visible.
See, I have lousy eyes, so I assume everybody wants things bigger, but maybe it's just me. So here's handwritten Python, and again, I'll tell you the same story about Python, like with the Julia, with the C, that even if you don't speak Python, I think it's even easier to see. We start off the initial sum to be 0, and for every element of our vector A, we just sort of fold in the sum, and then after we've gone through it all, we return. Right? Very simple kind of Python code. And so this becomes a Julia function. I've called it, sum underscore pi. And so now this is this Julia function. We wrote the code on Python, but now it'll execute on any Julia data. And so our horse race is going in, and we take a look, and we see, let me just get to the bottom here, and we see that, oh, this is horrible. This is yet another, this is 1,500 milliseconds. I mean, literally a second and a half to run.
How many people expected this? Of the Python?
That Python would be that bad, handwritten Python. I mean, it's just that slow. You know this for a fact. Again, if you only work in one language, sometimes you have no idea. You think you're measuring a computer, but you're really measuring a language on a computer. Many people have no idea. I'm not even sure I would have known this if I hadn't, run this for myself. So there's the handwritten Python. It's just crazy. All right. So now let's move into what we want to show you. Let's start. Before I do that, this is fine. Let me go right to the Julia. That's fine. So the first thing that I'll mention is let's run the built-in Julia function, which is sort of the analogy of the built-in Python function. And speaking to the fact about what makes Julia special for machine learning or any of these other languages, because Julia is Julia all the way down, it makes it very easy to look at everything. So for example, in Python, if you wanted to look at the sum function, you could. Actually, it's all open source, you could unwrap it, and you would see the C code. But nobody ever does that. Why? Well, I mean, you could, some people sometimes, but most of the time people don't do this. Well, first of all, many Python programmers are not C programmers. They're Python programmers. That's who they are. They're Python programmers, right? And so they don't read C. I mean, so, they're not any more likely to look at C code than I am to look at Hindi. It's just not going to happen. I mean, I don't read this language. It's just not my language. And even if you do read C, you're just not going to do it because you're in the Python mode, probably. I mean, unless you have some really good reason. But in Julia, everything's Julia all the way down, and so you can do at which, and right away the code comes up, and you can actually see that sum is implemented in MapReduce, and then MapReduce you can drill down, and you can actually see how the whole thing is working. And many people don't realize just how powerful it is to have a language all the way down. People rather just give me a library, I don't want to be bothered with this, I just want this thing to work. But pretty soon, when you have this power, you realize that you couldn't live without it. It's like, once you have a metro in Bangalore, you can't even imagine life without it, right? It's like one of those kinds of things, right? So this is the sort of thing we do all the time. So here's Julia. Let me benchmark it. Well, I guess I already did it. You saw me hit the return. And Julia is built in, which again, it's Julia all the way down. You can actually see the code is just as fast as NumPy is written in C. In fact, well, it's about the same, a little faster, 3.8, but to me these are both the number 4 milliseconds. Okay, and it's all completely written in Julia. So what I'm showing you is you can write code easily. You can get the speed of C, and if you want to call these Python packages, fine, good. You want the one that runs slower, go for it. You can go for it and have it, but you don't need to do that. Your choice. Nobody's stopping you.
So a small digression is okay?
It's very welcome. This way I get to sip a coffee and listen. Yeah?
How do you achieve the interoperability between Julia and other languages?
That's a good question. How do we obtain the interoperability? So, do you want to answer that, Vero?
Which direction are you thinking? Like Julia calling something or something calling Julia?
It's a Julia calling something.
So for example, with Python, we pretty much we have a package called PyCall, And
You saw me use it. You may have seen it go by quickly, but
and so we use Py objects and send stuff over to the Python interpreter. So Python has a way for you to call any Python code, and we invoke that API from Julia. So just like that, we do that for R, we do that for, except for C, in which case we actually, our C call will actually sort of generate the call stack itself and just pass the instruction pointer. So it's no different than any other C program calling a C program. So the overhead of calling a C function from Julia is the same as any other C function calling itself. So,
there's a bit more to the story, but maybe this isn't the place. So maybe I'll say a sentence or two, and if you want to talk some more afterwards, we could. But one of the things that I'm not bringing up is Julia's abstractions, where it's very easy to create. How do I say this quickly? Julia's language is remarkably flexible, and so that it makes it very easy to pretend something in one language can be the same thing in another language, and Julia's language fixtures makes it much just a breeze to be able to do this sort of thing. Okay, and I could say a little bit more afterwards if you'd like to see this in action. All right, so where were we? We have our horse race here. We started with a plain old C code. It was almost 9 milliseconds. We had Python NumPy, which was able to reorder the summation, and on my Mac get the parallelism even on one processor. We wrote that handwritten Python, and that was just the slowest little tortoise you've ever seen. We did this built-in Python, and that wasn't all that impressive either. And the Julia built-in, which I've even shown you the code, so that it's all written in Julia. And then the real question you might ask is, what if you wrote Julia code? So maybe you have this notion that all right, a built-in function, was written by somebody special. Maybe they did all sorts of tricks that you wouldn't know. So what happens if you write Julia code? So this is, if you did the handwritten, so we had the Python handwritten. It was way worse than some of the other Pythons. So let's look at handwritten Julia. So here's handwritten Julia for the same function. And again, it looks like all the other languages. Set S to be 0 and fold in one thing at a time until you've got the answer. There's Julia. And we run this, and what did we see? Did I get it running? Yeah. The handwritten one ran at the same as the C, okay? And there's no surprise there because Julia runs as fast as C, very typically. So this Julia code was running from left to right. That's what the code asked it to do. And it runs at about the same 9 milliseconds as the C does. And so here's kind of the summary if you're keeping score. This was the order in which we ran the computations. Here it's sorted by the numerical order. You could look at it either way, but I hope I've sort of convinced you that Julia really is fast, and I hope I've convinced you that Julia interoperates with any other language quite readily, so that if there's something that you've written in another language, or if there's a package you like in another language, and you're in love with your already existing code or these packages, we're not shutting them away from you in any way. You're still able to use every one of them.
Off topic, you mentioned something about not doing it from left to right, but doing it pair.
Yeah, this is sort of, people love to play games with how to do summations.
Okay, so is that kind of coming out from externalities and going out to the
Well, let's imagine every one of us had a number, right? And we're going to come up with a summation, all right? So here's what I'm going to, starting from here, I'm going to have Viral and I add up our two numbers, okay? Maybe Viral will remember it, okay? And I'm going to have Deepak and this gentleman add up the two numbers, and so forth, okay? And then what I'm going to do is, all right, everybody who's no longer in the game can sort of go to sleep, all right? And then we do this again, right? Whoever has two numbers now, and the next pair, the next pair, the next pair, and then again, the one who doesn't have a number anymore goes to sleep. Keep doing that until you have one number left, right? So that's the way Julia does it. And there are people who have there's all kinds of papers, and it's a whole specialty on what's the most accurate way, and people have arguments about these things. But the person who implemented it in Julia sort of studied all the arguments, and he's actually a whiz at this stuff, and decided this was the most accurate way. So accuracy is something else that we have to work on.
But you don't need to know all that when you
No, he's asking just for fun. He's
No, I
asking
know,
just for
but I
fun.
mean, I was just making the point that people do these things carefully, and they're just kind of, made available to you. But should you want to care,
But if you
can-
right,
can
if you
figure it
if you think that this is fun to know, and maybe 1 in 1,000 people care, but someone like you, but another 1 in 1,000 cares about something else, right? And the point is, everything is open in Julia. You can look at it and find out, and usually you can even find out why they did it. It's not just that they did it, but if you it's all open source. There's usually some comments, and you can even find out exactly why they did it the way they did, which is.
So I wanted to answer one of the questions that I thought you were bringing up about pandas and NumPy. Maybe a little bit,
My question was related to something else.
What was the question?
But I assume that, one of your questions, or maybe was that, does Julia have something like pandas?
Yeah.
Like,
So
I mean,
why I asked this question because
Trying to find this.
for training my training my model with my own customized data and preparing the data set, like if I'm creating any model, the model generally takes numerical number, float number, and all. Right. So anyway, I have to convert my data. So suppose I have text data. I want to feed those text data into my model. So I have to convert that data into either I can convert in vector, TF, or there are a lot of ways. Right. So how easy that in Julia?
so actually, this is one of Alan's favorite things, that he likes to take any data and convert it into a matrix so that he can do something interesting with it. We actually have a system called JuliaDB, which is an open source parallel distributed database. So think of it like parallel pandas at some level. And but it has sort of very fast data ingestion of various kinds, and then you can add your flavor to it. And it has a built-in method to sort of extract a feature matrix. So you can pretty much, for known data types where there is sort of no doubt about how to create it into a number, that's fine. But if you're string, it will just allow you to provide a method and then just call it across the whole thing and extract a feature matrix for you, which you can then hand over to any of Julia's linear algebra libraries or machine learning libraries.
So
Or send it from
we have to just use the library or the data, it will automatically convert the data into Julia.
Automatically, if it's obvious. If it's not, then you provide a helper function to sort of help it along. But you don't have to do everything, right? It's abstractions. So you just tell it how to convert one string to it, and then it will apply it across the database. So you don't need to worry about the distributed stuff and the parallel stuff and all the layers of complexity.
So since this came up, you might have seen me digging up this talk over here. So I was just recently asked to sort of give the keynote talk at the big IEEE Big Data Conference. And I would show them JuliaDB, the very system that Viral was just mentioning right here. And so I actually stole a talk that was given by some of the Julia computing people. Shah, for example, was right here in Bangalore, Jeff and Joshua in the United States. And let's see, I'm not going to go into the whole thing here, but let me see if I can.
One interesting thing about JuliaDB, while Alan finds it, is that it's...
this is actually a fun... Could I show the video? Just for fun?
Sure.
Everybody likes the video. May I show a video and then... hold your thought just a moment. But let me see if... Do I have... this isn't the QuickTime video. Let me see. Did I lose the video? I had it before. Let me see if I have it in QuickTime. What do I get? I had the video up.
It might just say last play recent or something.
That's what I'm looking for. Yeah. Yep, there it is. Good. So this is this is actually very funny, but it's also very true. So you see the title of this video. It says Modern Software Development, and this will give you a little bit of a feel for what we're trying to not do in Julia. So okay, so modern software development. So here we're trying to obviously plug in this plug into the socket, but it doesn't quite fit, so we try to find a piece of glue software, or in this case the real plug, as an analogy to glue software. All right, we'll just sort of do it half and half. Okay, why not? Maybe it'll work. Well, that doesn't quite work either. throw in another plug. And declare victory. We're happy. Right? Make a big mess out of things, but at least it does the job. Right? So, we at Julia think that we can do better than this. That maybe it gets the job done, but try to do the next thing now, and you have to hire 1,000 programmers just to make sense of what the previous thing was. So, what were we going to say? Will, were you about to make a point about JuliaDB?
I was just going to add actually that so machine learning is kind of integrated into the database. Not for the database itself, but for you. So once you know the data in JuliaDB, you can pretty much just start experimenting with a variety of statistical or machine learning algorithms without having to extract data and sort of, otherwise, you have to take pandas and then, create this thing and then hand it over to NumPy. But now if you want to give it to TensorFlow, you got to do something else. And our goal is to sort of integrate it all. And did you have that online stats?
Well, I'll get to that. Yeah.
Okay.
Yeah. But let me address the actual question. We don't believe that people should have to sort of go crazy converting integers to floats, or you could have many data types. You could have in Julia, it's easy to have colors. It's easy to have images. It's easy to have audio files. We believe that abstractions should persist, and so data is data, and we believe in generic programming, which means that if a function can work on that data, it should work on that function. We shouldn't have to go crazy trying to make it work on that function. And as Viral was pointing out, that when it comes to databases as a whole, we believe that databases should not just be a place to store data. This JuliaDB is not like your standard database. Right? Your standard database is a place to house data, do some very simple operations, perhaps.
SQL.
Yeah, SQL, whatever. We believe that the full power of a programming language should be available to all the data directly, not by pulling it out and working on it, but it should be directly available. And so this line here, batteries included, what we mean that tools for all kinds of analytics, machine learning, this was the first question that was asked as I was just starting to talk. Whether it's something as easy as adding 2 or running a full machine learning sequence on it, this should all be available directly to the database. And there shouldn't be like some wall that says that data lives here and analytics lives over there. And so that's kind of the reason.
Actually, database designers hate it for users to touch the data inside the database.
Well,
they're extremely protective.
Well, I have a belief on this, and I don't know if this is right, or I don't mean to be insulting, but I have a belief that database designers are not analytics people. They don't actually know anything about analytics. So they just sort of say, you other guys do it, because we don't. It's not
Right.
core expertise.
So you always end up with this, I have the database and I'm going to retrieve data from it and then do my analytics somewhere else, but data today is too large to do that kind of stuff. So the question is, what's the right analytical database design? And we decided to write a database in Julia itself so that you could run any Julia program in database, without moving data, without doing anything.
And as this was what Viral was mentioning before, and I'll show it to you right now. One of the things that we really believe in is that we wanted to make sure, to whatever extent possible, we want everything to work as an online algorithm. And if you haven't heard that term before, what we mean by that is that suppose you're calculating any kind of statistic of all, just the mean or a histogram or whatever it is you're doing, you should be able to bring in new data. This is what this cartoon is kind of showing. You should be able to bring in new data and get the updated statistic without having to go back and recalculate all the old data. And we should just sort of make this sort of a sort of expectation that not like a special library, but it should be like an expectation on the user that you'd be able to do. You should be able to update your information and be able to do it in an efficient way. And so we do this online stuff. We do it in parallel. Using the full power of the Julia language. And this is starting to catch on.
These things are pretty powerful actually, because they allow you to load pretty much any arbitrary amount of data, and the algorithms for online statistics are sort of guaranteed to run in a fixed amount of time for a new observation.
Yeah, so if you have a large data set and new data is coming in, you don't want to go back and recalculate. I mean, that's just crazy.
Can you illustrate these with some examples that people are already using that they can probably think about?
Well, this particular example was just simply doing something as simple as a mean, I think.
Are you thinking of like where other companies are using Julia?
To use some of
Can we load the Julia computing case studies?
Okay, sure. I had it here anyway, but I'll just do it again.
So you had some comparison on what's an AI ML stack with Julia and what do you see outside on a regular basis, and how if you already invested some in an AI ML stack, how can Julia really sort of supercharge?
Yeah. So Julia is open source first of all, so integrating it into almost anything should be pretty straightforward and easy to pull off. The way many of our customers are now beginning to think about this is that people used to think about, like I said, data and analytics separately, but with systems like JuliaDB that came up because of the need within the community, we are now able to sort of combine this step of loading data, querying it, and doing very simple queries on it, going all the way to sort of doing deep learning on it, or just about any kind of analytics on it in database. We think that's sort of the way things are going to move forward, and you don't need to actually know any of the distributed parallel computing in order to sort of do these kinds of things. So in terms of sort of a modern data and analytics stack, we think JuliaDB is the way to go. JuliaDB itself is open source, so feel free to try it out and give it a shot and report any issues you find.
My favorite 3 words are, and it kind of makes me smile, is it just works. So you move to a parallel computer, for example. Very often people ask, oh, well, do I have to rewrite the code, or do I have to sort of call a different library? And with Julia, very often the very same command that would work on a less powerful computer, it just works on a more powerful computer. To whatever extent that happens, every time my students know this, and everybody truly computing knows this, that if it just works, then I'm happy. And so that's what we're looking for with this sort of thing. You don't have to learn a special new tool set. Did you want to pick one of these case studies?
Yeah, I was just going to maybe walk through them very quickly. Yeah.
Just before that, so I've learned the basic lot
Sure.
of the entrepreneur crowd. So a lot of people have built systems in various different languages, different type of applications.
Like Alan was talking about in the sum example, or GPUs. For example, so Julia can directly generate code for GPUs. So when you use Julia machine learning libraries, you're not calling some CUDA-baked stuff, and you're actually writing clean, simple Julia code that gets compiled and executed on GPUs. There's actually a very popular blog post on NVIDIA's website about how Julia does it. So if you just Google Julia GPU, NVIDIA something, then you'll find that. And the same applies for distributed computing as well.
Any application in blockchain which was used?
No. It's a bubble. It's going to die. I'm just joking. Actually, so on the Ethereum blockchain, I can imagine Julia will be a language to write smart contracts because it's the tools are all LLVM oriented and driven, but maybe that's something you want to pick up.
There's a report on somebody. Remember that there was a report about somebody writing blockchain algorithms. Some people are trying it, but you don't know.
Oh,
yeah, it's definitely doable. Whether someone has done it, I don't know.
But since there's immediate money to be made over there and speed is matter and everybody is maximizing hardware, how come there is no application over there? Unless there was not market over there
It's special hardware, it has nothing to do with programming language.
It's probably not it's not a parallel problem.
Well, I mean, you have a lot of ASICs, right? So it's not even run on processors, right? I mean, so it's run on special purpose, ICs. I don't want to make this a blockchain discussion, sorry.
All this power of being able to compute with GPU, all this, is it coming from the LLVM infrastructure or?
A lot of it is. In fact, we are, we sort of patch LLVM heavily in order to make sure it does what we really wanted to do. So we do use LLVM as the way to target all the different hardware. But most of the sort of smarts are above the LLVM layer. So what can you do so that LLVM can do its job, and from the high level, very high level abstract language to the passes that Julia goes through, the compiler passes, so that then LLVM will do what it has.
So getting started in community in terms of activities that happen in Bangalore, what happens here?
Nothing happens here more than anywhere else. I mean, a lot of our community is online. So we do. So one of the things that we do that might be of interest is that every month we run a 2-hour session on YouTube Live to train someone who's familiar with another mathematical environment. I think in 2 hours they can pretty much get familiar and start using Julia. So we do a sort of a 2-hour session. The other thing that Alan mentioned is that in Bangalore we are planning to start a very large-scale training. I mean, in India actually, not just Bangalore, especially focused on machine learning, but that's in very early stages at this point. Beyond that, meetups and such, I think with the traffic, no one really wants to travel anywhere in Bangalore nowadays, so it's kind of hard. Although we did do an online meetup, right, recently, so...
December, we did one meetup. So we'll keep doing a few meetups.
We'll do more in-person meetups too, probably.
Or whenever Julia folks are traveling here, like Alan's here, so we kind of try to do events of this kind. But most of the community is online, so discourse.julialang.org is where all the technical discussions happen, and it's a very large community where a lot of people are.
So this program that happened earlier this week, was that published?
No, we did not publish it much because we kind of wanted to keep it sort of small and manageable, we hope that in the next 2 to 3 months we'll scale it up and sort of open it up to almost just about anyone who's interested. But if any of you are interested in it, I think maybe is Ashish the person to reach out to?
Yeah, I think we'll do that.
So we want to sort of figure out what the this is not I mean, as you can probably already guess, this is not a place where you come to learn TensorFlow. Yeah. I don't know if you've seen the TensorFlow owl picture. Have you guys seen the TensorFlow owl picture? So I don't know if can you Google on Google Images TensorFlow owl?
TensorFlow what?
Owl, OWL. How to draw an owl.
I haven't seen this before.
Oh,
owl?
You might like it.
Yeah, I've never seen this.
And go to Images. And if you scroll up, oh, this is the picture, that's right. So this is what I call sort of, on the right side, you're told this is what TensorFlow can do, but then when you actually follow the documentation and try to build that all, what you get is on the left-hand side. If Google leads you to believe that if you have TensorFlow, you can do the right-hand side, but you just end up with the left-hand side. So this is the TensorFlow owl in some sense. So that's not our intention with this. So we want to sort of, get people.
I really like this. It's so true. Okay.
Someone tweeted this. That's how I kind of found this thing. But our hope is that we can sort of, get sort of some of those basics. We are expecting a week-long sort of a thing that can get you really into the. So no libraries, for example. We don't use any libraries. You write every single line of code from scratch. But once you've done that, you can then imagine. Yeah.
No. Actually, we did. We actually then show them that you can use a library at the end of it all, so that you have both ends. From the bottom end, you can do it from scratch. But then, of course, you want to use libraries because they've been
optimized and all that stuff.
Right. So you do it from the top end, right?
So I mean, if companies who think that they just need to sort of have their engineers learn an SDK and just kind of do something, I don't think it's for them. But it's kind of like maybe one level deeper. Sure. Sort of people with some curiosity and want to think from first principles.
Or I would say people who intend to tweak things so that you can call it the evolving machine learning library in Julia is called Flux, right? I could actually bring it up if you want to see it.
So Flux is a pure Julia deep learning library, which it's some of its developers and us believe is sort of much easier to build, maintain, and
and I mean, the documentation is not even that bad, and even better is that there's this zoo of examples, language detection, anyway, there's a recurrent network here to do some character recognition. So, and the point is, you could use it like a TensorFlow, more or less, but if, the intended user would be somebody who actually wants to go in and not only get the job done, but might also even want to fiddle and see, what would happen if you added 10 parameters to your neural net, or you removed 3 parameters, or you tried to switch from this kind of neural net to another neural net, or maybe you even want to invent your own neural net. It kind of opens up possibilities, and that's what we're looking for in Julia.
Also, like if you look at reinforcement learning, right? Reinforcement learning is not available in a library, right? I mean, if you wanted to write alpha 0 chess, you can't just download TensorFlow and what do you do, right? So
some libraries are there in Python, but that is not very.
It's not part of TensorFlow. It's its own thing, right?
There's always some libraries, right? Yeah, somewhere, but
means if you want to develop some use case, you can.
Right. Yeah. But if you have convolutional neural net, sure, you can, but then you don't necessarily need TensorFlow. You could just do Cafe or something, and get running with it. Right?
So as a product, what we are looking for now, how I can solve my particular use case. I'm not worried about TensorFlow. I mean,
you've got a problem to solve.
You have a problem to solve, and you want to start thinking about it in a meaningful way and solve it. So most people don't have a billion images, right, to train the model. So most people have small data sets and they want to run some kind of a simple algorithm that they can kind of understand, that they can tweak, that they can relate to. And I think something like Julia is the right way to do it. It doesn't bake everything for you. I mean, but it gives you the tools. Can we load that machine learning blog post quickly, just to show it to people? I think.
How mature is Plex?
It's already being used by researchers for many things. So that's where it is at the moment.
Do you want to finish on Chinese, simplified Chinese, or English?
Maybe English. Yeah,
maybe English. Okay. All right.
So this was a blog post that we published about a month ago, and this is not about Julia actually. This is about sort of this whole point about like why a library approach to machine learning will not work. And we give a very sort of detailed set of arguments on what a real system for machine learning ought to look like. And to cut through the chase, the basic thing is that these frameworks are growing towards becoming programming languages. So why not just use a real programming language?
Why not just admit it? Like, this is a programming language. So, like, what are you afraid of to just come down and say that?
Start out as a library like in TensorFlow, and then they kind of added this TensorFlow, the whiles and the ifs and the it's kind of morphing into a programming language slowly, right? So, PyTorch said, we don't need that stuff. We're just gonna sort of, take this eager approach to it and then do things slightly, make Python a little more first class in the Torch framework. But I think, you just want to use a language that was designed to do these kinds of operations from the beginning. I think maybe that's good.
Appropriate place to come to an end. Okay.
I think the audience was maybe mix of developers plus founders. So I think hopefully some of the message
got a little bit for everyone.
Yeah. So did you have anything? Our thought was that this will be a kickoff for just AI/ML discussions, stack discussions, Julia itself with the community, and hopefully as the community is dabbling a little bit more and getting more conversant, we may have some additional deep dive sessions as a menu of visiting also.
Absolutely, yeah. I would love to.
Okay.
Or even on the net we can do, right? We can do a virtual
definitely
anytime.
So sort of a hangout session with the people so that you can connect back to them.
YouTube
sort of a
Live
follow-up
session.
Yeah.
And we also have specific questions from other people, so I'll share you that, and we can specifically, write them back. Yeah, right now the platform is a bit stuck with the internet issues.
Okay.
So, because of that, I've taken a note of all the questions. I'll share it with both of you, and once you have the reply to her, I'll forward that over an email.
Fantastic.
Okay, thanks.
Great. So we have some time for like just.
So sort of networking right now. So you got like 15 more minutes. Then they have to move to meet the media.
And we wanted to thank Sunil for giving us the space and the opportunity to sort of interact in this. There's an AMD GPU patch that's just landing.
And I was just wondering what's the status of that.
It's in the sort of the dev.
Yeah.
No, it's actually not that. I mean, it's just that there have to be enough users for it. That's the real issue. Someone needs to sort of own that patch. Apparently, it's an MIT student who's maintaining it. And it's in the master project. It's not slamming on it. But you can, what we do is just like bring in GPU, which are one very fast.
Okay, so they've heard or not heard? Yeah, they've heard. Exactly. If you want to say something to them, address them especially.
Sure. What should I say? Did they see this?
One second. Guys, just give us a second. Online audience is still there for you guys. If you want to say something to them, you can go ahead.
How they can connect back with you? I think the easiest way to connect is through our community and participate in the community, the Julia community online. So Julia, discourse.julialang.org is the place. I don't know if there are contributors out there. Maybe it's kind of hard to know who's online, but if you're keen, then there's GitHub. Julia Computing offers many of its products for free, like Julia Pro, for example. And if you're, I think I heard that there are some SaaS companies. So if you want to deploy Julia applications online, especially learning applications, we have a product called Julia Run, for which you should probably get in touch with Deepak here. But yeah, we'd love to engage, in many different ways, and it's a very large and welcoming community. Great.
Also,
but Google before asking.
Yeah,
if it's already been asked.
I'll just wave my hand, say hello, and thank you all for participating, and just if you haven't realized that Julia is really happening, and we encourage you to, as Will says, join the club. It's pretty fun.
Yeah, great. I'll just take a minute to just wind up.
Sunil.
If you've not heard, how many of you have heard about Lightspeed partners, or you're hearing it for the first time? Okay, half the people don't know. So Lightspeed has been in India for last 8 years, and we have made more than around 30 investments. And all the boards that you see out here are part of our investments. And we are the largest shareholders in Ovio, Fresh Menu, LimeRoad, and so on and so forth. So we are definitely looking at investment in ML, AI, SaaS companies, so do reach out to us. We just opened our space out here around 4 to 5 months back, but we have predominantly been operating out of our Delhi office the last 8 years or so. And we operate out of US, Israel, China, now in India. And we do tons of communities, so if you want to use this kind of a space for networking, just let me know about it, and I'll be more than happy to be hosting you guys. Just a little bit of background, I have spent the last 6 to 7 years with Google. I was heading the developer relations program, and I also started, I don't know how many of you heard about Symbian, so I started Symbian way back in 2005 in India, which got acquired by Nokia, and rest is history, what Microsoft did with them. So earlier to that I was with Microsoft, so that's my quick background. And now here at Lightspeed, I work with all my portfolio companies and help them bring up to speed on product, technology, design, and go-to-market strategy. So I come, what you realize at Lightspeed is you're making your investment is just your first part, and next 8 years what you do with them, that's where all the hard work and the heavy lifting comes in. So that's where me and my team comes in and takes care from there. So thanks a lot for coming in. So we've got some snacks out here. So let's network and get to know each other. Thank you.
Thank you. Thank you for hosting us.
No problem. Thank you.
See you guys. Thank you.